It's not very strange. I didn't get any manual, as usual with Chinese kits. I found some instructions on the web, but yeah, it's not that hard. All the components are marked on the PCB, one side only, and there's a 8 processor for it, and an LCD screen over here, and really good there's a socket for the 8 and so on. But I will do as usual, start with the low components with resistors, because there are some components you have to, well, do correctly so you don't burn it out, and I'm just going to show you some things when you power it up the first time so you can avoid burning too many components, I hope. So I'm going to start soldering resistors, some diodes and other very low building components. And I have made some progress. The resistors are in place. The capacitors we have to 22 microfarad. We have a 104, so that's 100 microfarads. It has been that I'm slow in the head today because I have a slight summer cold. Well, these are not any problems with components, and we have these are polyester capacitors here, which will be next to relays and the small diodes. The only thing with the diodes, turn them in the right direction. There's a marking on the PCB, and that's the same as the small line on the diode. Nothing strange. Now we get over to some components that are a bit different. First of all, I have one leftover resistor, which is not a resistor. This is a small inductor. As you can see, it has a different color of a body, and it goes next to these two 104. There's 10 microhenry up here. That's this one. That's strange. We also have an inductor, which looks a bit strange, and if I'm not totally wrong, it should not matter which direction we turn it in, but it goes down here, 82 microhenry. As of course we have a switch, which I haven't picked up yet, and then we have 3 transistors, 2 9012, that's PNP transistors. Check that you have the right transistors and the right orientation, and you have the 8050, that's an NPN transistor, and also check the orientation. And then we have our voltage regulator, the 7805, so that's a 5-volt voltage regulator. It's going here, it's going flat like this. You have to bend the legs down because we can put the LCD display on top, so that's not strange. And we have the smoothing capacitor for the voltage regulator. Let's see, can I pull it off? Paper, go away. So this is a electrolytic capacitor, so you have to check minus and minus on the PCB, so this is going this direction. And then, to have room for the LCD display, you have to pull up a bit, and then I'm using a screwdriver to bend it so that it stays down close to the PCB. Of course, when you solder it, check that it gets flat and nice, and that's almost all components. We have 2 capacitors left over, a tantalum capacitor electric, well, I can't pronounce it. They are polarized, and if you look at them, normally there's a text that says 10 GF, and they are 10 microfarad. And there's a small plus sign. That's a positive lead. In this case, it's the long leg. And if you look at the PCB, you see a line marking. That's the negative side. If I'm not totally wrong here, I'm trying to follow the PCB and check it. So if everything's correct, this means in this case, the left one, I'm gonna have the markings towards me, so I have a positive leg on the inside and negative on the outside, or to the left. And then the next one is the other way around. I'm gonna have a marking away from me and a negative leg on that side and positive. If you turn these capacitors the wrong way around, the meter won't work. So these are a bit tricky, and a little bit capacitor here and the inductor here. So I'm gonna put the rest of the stuff in place, like the socket for ATmega and the rest, and also these components. So wish me luck. Now we are getting somewhere. All the components in place. The things I've left over is the LCD display with its pins and the ATmega and the battery connector. You're supposed to use this style and then the connection, and it's very nicely marked on the PCB. It's negative on the outside, positive, and a pin in the middle if you're going to use that. But I don't want to any loose stuff, so I'm going to save that one and take a 9-volt battery connector directly. I'm going to run it through the hole in the corner up here, and then we have 3 plates. And if we turn around, we can see that the top plate and the side plate are connected and are going to the middle pin of the 7805, so that's the ground. And the other one here goes here and to the first pin, if you turn around, the left pin, and that is our little input on the 705. So that is negative, negative, and positive. So I'm going to use these two so I don't get confused. Negative and positive. And the other thing that wasn't in the kit is here's the connections for the components I want to test is capacitors, inductors, common in the middle, and a little capacitor to the right. This one I will not use D10, we're going to that later. But I have some normal stiff lasers, and what I'm going to do is I'm going to cut off 5. As you can see, I have to lose 2 of the legs, and then the 3 left over will function as easy ways to test components. So I'll do that, and then we're going to power up and do initial power up testing. Okay, we are going to do a power up test. For that we need a 9-volt battery and no ATmega installed, no display installed. The rest is in place now with the sockets and everything, and the op amp is even a Texas Instrument op amp on the input, so some quality products or components, sorry. So let's see, 9-volt battery, correct orientation, whack it in place, and no smoke. And step 1, I don't know if you can see the meter. Just use the solder as a support. Stay put so I can read you too. Let's check the 9 volts. We have ground, and we have positive, and we have no voltage. Come on. 9.05 volts. Good. So that's our ground, that's our 9 volt. Let's check the 7805. We have 9.05 on the input, and we have 5 volts on the output, and the battery is not getting warm or anything, so there shouldn't be any short circuits. And Now we're going to check the power to the atmega, so that's correct. We have 5 volts out from the 7805, so it should be correct, but let's double check. And you start on this side, you count 1, 2, 3, 4, 5, 6, 7. That's the VCC in, and straight over from that you have leg 22. That's ground. Let's see. And we have 5 volt and the right polarity. So now we're going to put in the atmega and the display and see what we can look at. And we do the final power up. We are put everything in place. When you put in the atmega, double check you put it in the right direction so you don't burn the microcontroller. And it's on. We have backlight. And we can't see anything. You have a 10K potentiometer up here. That's the contrast setting for the display. So let's see if we can get something nice to look at. Look, a bit too much. That's good. And now, last thing we're gonna trim is the 5K potentiometer down here. There's a TP test point minus positive, and we are supposed to measure DC voltage. We're gonna put it down there, and it's also printed on the PCB. 3.16 volts, that's the voltage you want to have, so we do not have that. Let's see, we can adjust it other way. Oh, 3.16, come on. This is multi-turn potentiometer, so you can turn it a lot of turns. Oh, it's sensitive. Come on. Oh, there's nothing strange about it. Let's see. When it drops down, where are you? 3.16. Yeah. Now I don't have any inductors lying around, but I have some capacitors. So let's see. We have a test button down here, which you can choose capacitor. 0.3, there's nothing connected, and inductor. And then we have electrolytic capacitor, CE, you have to put on the right side. Below 500 microfarad, above 500 microfarad, and then back to the capacitor. Let's see if I have something lying around here. Not bad. Yes, just grab one. I will not do a full review testing it with a bunch of components. I will just choose one randomly. Let's see which one it is. 22. Let's see if it works. Down it goes. And capacitor. Oh, sorry. 23.1. It's supposed to be 22. No, not so bad. And you see, it's nicely sensitive. Let's see if we can take some of her, dig in the bag. And we have another value just for checking. And it's a 75. Let's see. 73, 72. Yeah, works nicely. So the big difference between these two is for larger values and for diodes and transistors and stuff like that. This is really good for low value capacitors and inductors and electrolytic capacitors. So that's that. Surprisingly, my first build with no problems, or almost no problems. So take a look at this if you need something to check small values, and it's between 10 and 50 euros, something like that. So quite cheap kit. And well, good luck and see you later.